Okay, welcome back for session 5. This is our last session of the day. So just a couple of administrative announcements, especially if you are just joining us or have been popping in and out for different meetings and sessions. We are recording this session. I just kicked off that recording. The recording and other meeting materials, including notebooks if applicable, and slide decks will be made available after the event concludes. Just please, a reminder, give us a few days to turn those around and make sure they're 508 compliant and accessible for all. There will be a Q&A portion as long as time allows. For instance, with our last session, we didn't have time for that Q&A, but we recorded the questions so we could get those to our presenters and get answers and get those published out on the CCSQ DNA portal as well. So with that, I think, just a reminder to put your questions in the chat so we have a record of all of those. Team members may be answering in the chat as well as verbally at the end. And I think that is all of our administrative announcements and reminders. So with that, session 5, our last session of the day, is SAS to Python conversion. Learn how to use SAS2PY to convert SAS code. Clearly, it's been a long afternoon. And that's going to be with the AIM team. So I'm going to pass that over now. And they can kick things off and give more information about themselves in their session. Thank you.
Great, thanks, Julia. When you go to the next slide. So here's the agenda today. We're going to start with some brief introductions. I'm going to go through a few slides as a presentation, and then we're going to spend most of the time doing an end-to-end demonstration of SAS2PY, where we will actually start with some SAS code, go through an analysis, upload that SAS code, go through an analysis, a conversion, an execution, and data getting ready for execution in Databricks, and then a data validation step. So when you can see that I have several of our SAS migration experts here with us, Parv Joshi, Suman Adari, and Patrick Miller, who will be doing the demonstration for us. And then hopefully we'll have some Q&A at the end. But I'm going to go through these slides fairly quickly. If you've attended Data Camp in the past, you've seen some of these before, but there is some new information. Next slide. So just brief introductions here. My name is Ashley Miller. I'm the technical lead for the AIM SAS2PY product itself. And you can see the other names here who are SAS migration experts on the call with me. This is part of the SAS2PY at CCSQ is part of the AIM project, and Nana Idu is our project owner there. And there is a DevOps component to this as well, which is handled by Fedor Filanov. And next slide. So why SAS2PY? So as we all know, SAS Via is being decommissioned, and we want to transition to an environment that provides more, this isn't just a cost savings issue. We want to transition to an environment that is more open source, provides more performance and scalability. And, Katie Holmes mentioned this in her opening remarks, that this is really a new way to manage and use data at CCSQ. SAS2PY is a developer's tool, and the tool is used to analyze and convert SAS code to Python PySpark code. And this last bullet is important. Once you've done your conversion over to Python PySpark, there are no more runtime dependencies on the SAS2PY product itself. So the code runs entirely independently. There's no licensing cost for the code that was generated or anything like that. Next slide. So just a quick rundown of some of the SAS2PY features. The first bullet is actually wrong. We have already upgraded SAS2PY to version 3.2.1. It was updated late yesterday, actually. When you upload your SAS code, you're going to get an analysis of that SAS code, how many lines of code, how many files there are, if there's multiple SAS files, how many proc statements, what type of proc statements, and how the code references other code blocks, and the data, how that flows through the system as well. We call that code and data lineage, and that's presented to you in a graphical fashion. Of course, we do the automated conversion. It really is a one-click conversion. You just choose which environment you want to generate your code for. Is it Pandas, generic PySpark, or Databricks, or Snowflake? The code that's generated is PEP8 and PEP257. So this is generating code that's following these standards for documentation, code generation and documentation to make it readable and maintainable code. As you use that code throughout the life cycle, for however long you're using that code. When you generate the code, you can actually generate it as a .py file, a standalone .py file, or you can generate the code as Jupyter Notebook. One of the newer items is MerlinAI. This is a coding assistant that's built in. It has a large language model behind it. We'll talk a little bit more about that. And then the DataMatch for data verification. So you want to make sure that the data that your new code is producing is the same as what the SAS code was producing as well. Next slide. So I'm just going to go through a few screenshots. This one is actually the file metrics. This is part of the analysis phase. When you get your file metrics, you can do it on a file by file basis, or you can do it on a project basis. So when you go when you log into SAS2PY, you create a project, and then you can upload one or more SAS code modules as part of that project, and then you can get these detailed analysis on individual files or all the files that exist within a project. Next slide. So here's the graphical representation of what code and data lineage looks like. So you'll see each of either the code modules or the data sources and the connection between each of the blocks. And when you zoom in on this graph, there's actually icons that you can choose directly from this graph to take you to the data sources that if you're looking at the data lineage or looking directly to the code source, the SAS code source, if you're actually looking at the code lineage. So there's ways to navigate through your code in a graphical fashion using code and data lineage. Next slide. There is a full code editor built in to SAS2PY, and you're going to actually look at your SAS code and the generated or converted code side by side. We break the code into different blocks of code. So you'll see it's kind of small in the screenshot, but we break the SAS code into blocks, and there's block IDs associated with those. And those same block IDs can be referenced on the PySpark side as well, on the converted code side. So that you can look at what code was generated specifically for each SAS code block. And next slide. So the DataMatch utility is very important, right? This is so that you want to make sure that the code that was converted and is now running is generating the exact same results as your SAS code was. And so DataMatch is a utility built into SAS2PY to provide that functionality. You get some very detailed graphs and HTML reports on rows, as really granular rows and columns. How many rows matched? Was it 90% or 100% data match on your rows? How about your columns? Were there columns missing? Those kinds of things. So this is a great tool for helping you understand that the converted code is actually producing the same results. And next slide. So built into SAS2PY is MerlinAI, our coding assistant, and you can access MerlinAI by clicking the little wand icon, and that wand icon is available throughout many of the different pages within SAS2PY, application pages within SAS2PY, and you can go in and just use natural language and do things like explain this code to me or help me optimize this code. Next slide. So these are the user metrics for SAS2PY since it was first deployed at CCSQ back in January. So you can see the increase in the number of users. We're actually capturing these metrics across SAS2PY. So you can see how it's increased since January, number of users, number of files, number of projects, number of code blocks. We're showing here also the number of proc statements, and also we're breaking the proc statements into the number of proc SQL statements as well. So these are metrics that we're collecting on the usability, on how SAS2PY is actually being used. And next slide. So this is how this is how SAS2PY is actually deployed at CCSQ. It is in an ATO'd CMS AWS account. You access it through your browser. When you log in, you use your HARP credentials to actually log in to SAS2PY. And once you're logged in, you're going to create a project, upload your SAS code, analyze and convert it. Once the code's converted, you download that converted code and take it over to your Databricks environment. We're going to walk through this in the demo. Next slide. So some new features that are upcoming. So these are not in the 3.2.1 release, but are planned very shortly. The direct execution of your code in Databricks within the SAS2PY tool. So you will no longer have to leave the SAS2PY environment to actually execute your converted code. One of the other items that we've actually done recently is instead of taking SAS code as an input, we've taken PL/SQL as an input and generated PySpark code. So if you're doing just SQL types of conversions. So in this particular case, we had an application that uses Oracle PL/SQL, and we're moving that over to a PySpark environment. And then we're continually making improvements to SAS2PY. There are some improvements in code conversion, and we continually update SAS2PY in the CCSQ environment. The next planned release is a 3.3 release with significant enhancements in the code conversion area. A couple of items that are also being looked at, these are not so much affect you as an end user, but we're going to be moving from a local Postgres database to Amazon RDS Postgres, and we'll be moving MerlinAI. Right now we're using a local large language model running on an EC2 instance with a GPU. We're going to be moving that to Amazon Bedrock. So these are transparent. These last two bullets are really transparent to you as an end user, but again, some more enhancements around SAS2PY to help with scalability, to improve scalability. And next slide. So there are a lot of resources available to you out there as you get started with SAS2PY. So on the Data and Analytics portal, we have a training page. There's some how-to videos out there. There's, of course, the user guide and an FAQ. For assistance, you can contact us. You can contact the support team at the service center. Ask for your ticket to be routed to AIM SAS2PY support. We also have a dedicated Slack channel called QNet SAS2PY, and we're constantly monitoring that. And so the people that will be doing the demo, Parv, Suman, and Patrick, and others are monitoring that SAS2PY channel with any questions that you may have. That is you have to request to join that channel, so you do need to make that request. And then we have office hours that we hold bi-weekly as well. Next slide. Was that it? I think that might be yeah.
Oh, sorry, my deck glitched.
Okay, so I'm going to turn it
There
over.
we go.
I'm going to turn it over to Parv Joshi. We're going to start our demonstration now of an end-to-end analysis and conversion. Parv's going to start us off. So Parv.
Sounds good. Parv, at this point, did you want me to drop sharing so you can take over?
Yeah, sure.
Okay.
Hey, let me know when you can see my screen.
I can see it.
Awesome. So I'll be starting with the initial part of the demo, which is about getting started, how to upload your files and analyze them, and also show you a little bit more about the metrics that Ashley showed in his presentation. So first, to log in, I'll go to the DNA portal, log into my account at my portal. Like if you have a SAS viral, you should be able to see this SAS2PY chart, and just clicking it would sign you in directly in here. So this is the SAS2PY homepage, and over here you will see a list of all your projects. I already have a few projects in here, but it might be empty for you if it's the first time you're trying to log in. So the first step I'm going to do is create a project. So basically, project isolates your work from different projects. So basically, you can just upload multiple files within the project and have everything bundled up inside that. So I'm just going to click on the Add Project button in here, and I'll give it a name, say Demo 3, 513, and just give it a description of as well. Okay, demo. So everything else is optional in here. And also, yeah, do keep in mind that project names like required to have like lowercase letters and basically no symbols other than underscore and no spaces as well. And if you try to make a name like that, it will tell you that this name is not allowed. And also project names are supposed to be unique across like all users. So you won't actually see the projects for other users, but if that name already exists, it will again tell you to pick a different name. So just to keep that in mind, and it will show you adding project, and it might take a while, and uh, basically you should see the project directly in here. So demo 513. If you do not see it, you can click on the refresh and it should be available then. So the next step I'm going to do is just click on it and it will take me to the project metrics tab in here, and it will automatically select the project for you. So normally, like if you want to just manually go over, you will go to the project metrics and select your project. But just clicking on the project here will do that for you. So it's pretty simple. And over here at the top, you have option to upload files, analyze files, convert files. And basically, this is like the whole metrics of around that. So I'm going to upload files. So at first, let me actually show you the sample files I have in here. So I have this folder called demo files, and there's like two different folders, part one, part two, and then each of them has three demo files over here. So one thing to note is SAS2PY doesn't really like these uppercase letters, whether it's in folder names or file names, and even the spaces. So what the tool does is it's going to reformat those just to have a standardized format similar to the one I mentioned for the project names. So you can actually just directly drag and drop. Okay, let's go back here. So if I actually try to upload this folder directly, it would not preserve the file structure. It'll just upload all the files at once. So to circumvent that, we actually support zipped files. So if I zip that particular folder and upload it, it will preserve the file structure, basically like the part one folder and the part two folders I had, and then the three SAS files within them. So I'm just going to click on upload. And once this is uploaded, it'll basically start analyzing these files for you automatically. So what the analyze function does here is so okay, over here you have the message saying it's uploaded successfully. So if you refresh, you will see six files in here, and three of them are analyzed. And if you give it a little bit of time, you'll see six of them will be analyzed. And you can also like keep track of it using this notifications panel. It says demo 6 was analyzed and things like that. So I'm just going to clear all notifications. So just to explain what analyze is, so it's basically a dry run of the conversion itself, where it splits all your code into different blocks and then um, understands the code, maps it with different code blocks, like and basically finds lineages and associations between data, the files, the code blocks, and things like that, and also fills up these metrics once they are analyzed. So if I refresh again, you can see that all six files are automatically analyzed. And I also have these metrics that have popped up. So total number of lines in files. So this is for like the entire project at once. So all six files included. It's 622 lines, out of which 430 are code. The rest of them are comments. And then how many were processed, basically analyzed, and then how many errors were found in here. And also you can see like more information about these. So this is more about percentage, how many of them were processed and things like that. And basically the same information in different kinds of charts. So this is by lines of code. So basically it tells you how many lines of code were like are in to do, how many are analyzed, how many converted, and basically like the steps beyond that as well. And in in here we also have some more statistics. This is for each file. So this is like demo1.sas, and it shows you like the same information, the lines in file, lines in code, and lines of code and total blocks, whether they were passed, failed, how many errors were there. There's also a complexity that basically gives you like an indication of how much complex you might expect the code to be in like relative to the others. So this one's just for your information. You can also basically you can see these filtering options. You can filter by minimum or maximum in here, and you can also download this report as a CSV if you need to do like further analysis on your own. Over here, we also have block stats. So basically, this gives you information on the different kinds of code blocks we have in our project, and this is across all files. So if I click on libname, I can see basically there's this high-level summary that is like how many lines of code does a libname have in all these six files combined, and it's 12. And then it basically gives you a split for each file. And there's also, let's take proc frequency. So this one's only in demo3.sas and not in the other files. So it'll just give you this same information for these. So this is how you can basically get some more information on a project level about the files you uploaded. And all of this happens while analyzing your files, and which is actually an important part to do because you cannot convert files unless you have analyzed them. And over here at the top, there's also an option of downloading project reports. So this downloads an HTML report with basically the same things. It's like the project level report. And there's also a download comprehensive report, which is actually a zip file that includes the same HTML file as this, like basically the project's report, and then an file, like an individual HTML file report for each file like you have uploaded. So basically it's like one project level and six uh, like SAS code level, SAS file level HTML files. And basically how those HTMLs will look is basically what our file metrics page is about. So over here, I'm going to select my project and then select a particular file. And now I have the same information for that particular file instead of the whole project at once. So basically, yeah, the number of lines, how many blocks were processed, how many were passed. And also now we have like a bar chart of the number of like the kind of code blocks and the number of code blocks we have. So there's 8 proc sequels in here, and then 12 comments, and I can change this from process blocks to lines of code as well. And then there's also an area chart equivalent for this. And then we also have the same information in a pie chart here. So there's like proc sequel, data step, and libname in here. So let me actually pick a different file. So yes, over here you can see we have upstream files in this. So basically, this is demo6.sas, and this is dependent on demo5.sas and demo3.sas and these other files. Also, we are taking an input data set called all data dot project data, and these are the output data sets for this particular file. So basically, this basically gives you like the whole file level metrics for this particular file, and then you can do it for each file. And again, there's a download option in here, but of course that is included as part of the zip file in here. So you can just download all at once using this option. So the next thing I'm going to show you is the lineages. So there are several types of lineages. The first one I want to show you is the data lineage. And this one also, there's a project level one in here. So if I select my project in here, I can see this entire graph. So if I zoom in and see, so over here, what happens is each node is a data set. So this one is a data set named reports.employee performance. And this one is high performance. And over here, this tells you where the change actually happens. So in demo 6, we basically like take this as input in a particular function and then write out this particular data set. So this is the dependencies of like how the data set is being evolved and modified throughout the entire project. And this might be a little complex because there's like a whole lot of things just from these 6 files. So to simplify things, you can look at it as a file level as well. So over here, I'll select the project and then select a particular file. So in part 1, I would take demo3.sas. So over here, it's pretty much the same thing. The nodes are data sets. Over here, it's combined.valid sales finance. And this is basically combined.average sales to budget. And there's an operation of proc SQL within this file demo3.sas where this data set is being changed to this one. So basically, it's giving you an information of the flow of data and how it's being created throughout like this particular file. And as I mentioned, there's like project level and file level to give you like a more comprehensive information on how this works. The next one is file dependencies. So this one is a similar lineage, but in this case, each node is going to be your SAS file. So over here, I have demo3.sas. And then there's an arrow from demo1.sas. That means demo3.sas is dependent on demo1.sas. And over here it says data set. So it basically means an output data set from demo1.sas is being used as input in demo3.sas. And basically the same thing in here. So there's different operations that could be here. Sometimes it could be like a macro call instead of data set. That means a macro was defined over here and then being called in here. And there's also block level MerlinAI statistics you can view as well. That is something we'll see in the later part of the demo. So this is basically a brief introduction of how to upload files and analyze them and view the metrics around it. So now I'm actually going to pass it on to okay, actually, before I pass it on to Suman, I wanted to show you like if you want to share basically a particular project to a coworker, maybe someone from your organization, there's an option of doing that in here. So there's this option called Manage Access. And you can see I am the owner over here, and I just have to search for the person I need to give access to. So I know Suman's harp ID. So I can just click on his thing and I can give him editor access or view access. And I'm just going to give him access to this particular project so he can continue in the same project in the next part of the demo. But yeah, keep in mind that whoever you want to give access to has to have logged into SAS2PY so that their user is registered as like they are registered as a user of SAS2PY, so you can basically allow them access. So yeah, I'm actually going to pass it on to Suman now. So let me stop sharing. Yep.
All right, thank you, Parv. So we'll take over from here and let's get started. So I have my SAS2PY window open right now. I have more projects in this case, but in particular, the project that Parv just shared with me is right here. So Parv went over the project creation, file upload, file analysis. I will now go over conversion, as well as how to take it to Databricks and how to execute it in Databricks, and how you know when it's correctly set up. So first off, we got our project here. Everything looks about right. I can see the project page and everything, all the metrics that Parv just showed you. But now I'm gonna go over how you can convert this. Let me bring my Zoom tab here. There are several ways of converting code. On the projects page, this is somewhat recently added in, where you can have the entire workflow cycle right here. You can control all the buttons are available to you. You can do upload, analysis, and also convert. So I can convert the entire folder all at once. I won't do that right now, but I will show you the options that are available to you. There's PySpark, Pandas, Snowpark, Snowflake, BigQuery, Databricks, and there's a lot more, but those features have not been turned on for us because we don't really need them. I think for AIM, he's running on Databricks, and yeah, you also got the option of PySpark. So for now, I think PySpark and Databricks are equivalent because Databricks runs PySpark, so they're kind of the same here. Um, so it's okay, you can pick either one and take it to Databricks and you can run it. But the other way to do it, and this is not really the most encouraged of ways because things are always changing, but this more has to do with the internal mechanisms of how the projects are stored. You can go to your file manager, you can go to your project, and in this case, for the time being, we know that the outputs are stored in staging, and that once you've analyzed everything, it's analyzed. This has changed in the past, so I don't recommend this method. That's why we streamline. We have the buttons over here. It's been streamlined, so the users don't need to do that. But this is another way to do it. You can go to analyze demo files, go to a particular file you want, and you can convert the whole folder here. In this case. Or you can go to the converted tab, which is the most recommended way of doing it. And that's because you have the option to view the entire workflow in the file right here. So this is every code block in demo 1, and code block in this case refers to how much the SAS code can be split up into these little code blocks based on common functionality, right? So if you have a data step, that is going to be considered one code block. If you have a bunch of let macros, let me zoom out on this page, hide this, you can see. So here's some lib names. Zoom in a little bit. So here's some lib names. This has been considered one block because it's just basically a lib name. That's what the block is called. Here you got a data step, a data line step actually. It's creating the data set sales data. And that's why this has been considered a block. So you can kind of see the entire workflow of this all at once. That's why this tab shows you here. And you'll notice this MerlinAI has been integrated into a lot of different places. We can actually run this and see. So I clicked on this particular block here. I'm going to ask it now. If I click on overview, it's going to tell me what that block does. So this integration is still a work in progress. As actually mentioned, we're switching to Bedrock and also making it more complex in what it can do for you. And yeah, here it just goes over what the SAS block of code does. So yeah, so you have this lineage view of the entire file. This is going to show you how everything's pieced together inside the SAS file, right? So this right here, the sales data is used by all of these guys here. So this subsequent data step, a proc SQL over here, another proc SQL, and so on. And this one, the output of this proc SQL is used again for this later data step. So this really gives you a good picture of how things work in your SAS file. This way, you won't really get this understanding if you look at the notebook. It's a lot more difficult to do that. And actually, there is this thing called execution mode that is a new feature as of 3.2.1. Currently, it's not functional because there's still some additional work we have to do to set up stuff. But what this basically does is in the future, you'll be able to execute your SAS blocks right in SAS2PY. So you don't need to go to Databricks. You don't need to look at individual cells in the notebook. And if your program's like thousands of lines long, it's actually a pretty miserable experience to try to do anything in the notebook when you have that many cells and you have to run everything beforehand and so on. So this is the more streamlined approach where you see it right here, block by block. You have control over what you want to execute, right? So obviously you would execute this, and now say these two work fine, but this one has a bit of a problem that you're trying to remediate. Now all you have to do is just run this, and go directly here, and you can try to make your changes and remediate that way. And then you can run it directly in here. And then if it works, then you move on. If it doesn't, then you can keep at it. This is much more preferable to Databricks execution where let's just say you have this cell, this cell, this cell, this cell, and then you got to run this cell, and it's hard to keep track of, and it also gets pretty messy. So that's what's coming up in the future. I just wanted to point that out. Currently, it's not functional, but that's what's coming up. But the main highlight of this is you can do code conversion with this, right? So I'm gonna take this and I'm gonna convert it to Databricks. Click on this file. And I'm going to open this code editor view. So on the left, we have our analyzed block of SAS code or analyzed SAS file. This is the entire SAS file. You can see that these block IDs have been inserted into the SAS file. So let's open up our Databricks code. Might take it a bit to convert. We'll give it a second there, but the block IDs are equivalent to what they are in Python, right? So let me just try to PySpark. Might take a second to convert, but just in case, I do have the file converted from earlier, and we can move on to Databricks from there. All right, I think we can probably move on to Databricks then. You'll see the Python code there. So let me switch share to my Databricks workspace. Okay, this is my Databricks view. So I'm going to take the notebook and I'm going to put it in. So this notebook here has just been converted earlier. So this is a file summary. It gives you, it didn't find any error blocks, but it kind of splits up the blocks by what it saw in the file and gives you summary in the first cell over there as a comment. So this right here is, if you're familiar with the Databricks execution guide, which you can find on the DNA portal for SAS2PY, this right here is a default kind of import header that comes with the converted code. And what you need to know is in SAS, there's a lot of things like proc means, proc SQL, proc frequency, all sorts of things that are pretty easy to just write out. Like if you want to do proc frequency, it's just like 3 lines of code in SAS. But under the hood, there's a lot more going on because the code that actually defines what proc frequency does is hidden away from you somewhere else in a black box, right? So that's why to do exactly what that does in SAS, but in Python, um, SAS2PY comes with a lot of defined code, predefined code that is stored in a specific place on Databricks here, and I'll show you that in a bit. But it's available for everyone to see if you're interested in looking at the inner workings of these Python functions or just getting to know what else you can do with it or how you can call it, etc. That's all going to be available for you to see. And I'll go over that in a few seconds. But basically, this import header we need to fix because this workspace path is not where our predefined code is. So let me pull up the execution guide. So if I can go here, yeah. The place you're actually going to find this stuff is going to be over here. Workspace, CCSQ, Code Commons, SAS2PY, Common. So this is the path you need to give it, and then it'll know where to find this. And that's not the only step. Actually, let's connect our cluster. That's not the only step. So once I have my cluster connected, you need to also install a few packages. And actually, a few things have changed with Databricks. Everyone now has their own cluster, which means you can pre-install these packages. Either way works. You can just do this every time you start up a cluster, or you can put these packages in your cluster to begin with. But let's first run this. It'll take a few seconds to run. In the meantime, let's yeah, let's just go through the rest of the code real quick. So yeah, this is one of the first blocks that got created, the data lines. So this is where the data was defined, and this is how it's creating it in Spark. There's a lot of custom defined functions that shorthand a lot of the functionality into functions like this. There's a lot of custom functions like that. This is a dynamically generated function that does something defined in the data lines. Right here, it's formatting date into MMDD YY10 format. So that's one thing it's doing. Down here, it's a proc SQL that's been converted to this format. Yeah, the rest of this file is pretty straightforward. There's a lot of SQLs going on. And yeah, so that's the Python file. Now let me show you. Once you've got this import header done, you're going to want to execute this, and you'll know you're ready to run the rest of the file if you finish running the cell and it looks like this, right? So this is what it looks like. So now if you see something like, I think, like this in the code, well, that's actually defined somewhere. Now it errored here because I didn't give you anything, no arguments to run with. So no data frame, no data, no table statements, whatever. But the important part is it now understands where to find all this predefined code. So once you have this finished, it's going to look like this. This is not an error. This is just logging statements. And when you see this green check mark here, it looks like that. You're ready to run the rest of the file. Now, I will say sometimes it might run perfectly fine. Like, let's try running this here. Sometimes you'll run into errors where it might need a little bit of tweaking or a lot of tweaking. It's very dependent on the file. So if you have something complicated like SAS Enterprise Guide, the conversion rate is not going to be as high as the average of, let's say, 90%, 85%. Enterprise Guide is more difficult, a lot of machine generated code in there. So conversion on that might be requiring a bit more manual intervention there. Like, for example, if you see a lot of retains going on, retain is not exactly automated right now, but you might circumvent that by understanding, oh, this is the intention of the code. Let me rewrite it this way in Python, and so on. So it really depends. So in this case, it did execute. It created this data set here. We can basically view it. That's already viewing it, but oops. We can just do .show, and it looks like it indeed did the data lines. And you can just keep going on and so forth. But once you got to this point, you're basically good to go. You got your file over to Databricks, and you're executing it, and things are done. So at this point, I'm going to hand it over to Patrick, who is going to go over, once you have your Python code executed, all right, and let's say at the end of the program, you have several data steps that are creating data sets and saving it somewhere, or creating a table that you're expecting it to be output. How do you make sure this output generated by Python PySpark is matching the outputs in SAS, right? And that's what Patrick's going to go over, the DataMatch utility. So hand it over to Patrick.
Okay. Sure. Okay. So this is the DataMatch tool running in Databricks. Move this out of the way. So Suman already went over the first few lines. So this is just installing some modules and setting up SAS2PY and Spark. The one difference is that this time you also have to do a DataMatch fast import, and I think that's the only difference here. So to actually use the tool, you just need the two data sets. So the first data set and the second data set paths, you read those in, you give a name to the report you want the DataMatch tool to make, the path to where you want it to save, and then the columns for the primary key columns and the columns that you would like to compare. And then you just run the script, giving it all that information. And the CXT is just the Spark context, and that's created and the initialization function above. And then this code here is just to print out the report, because the report's an HTML file at the end. Okay. And then we can go over some examples. Okay, so this is the code just doing the initialization at the start. And then we have the first simple data set. It's just 5 columns by 10 rows. And the first case is just when everything matches. So the data set B and A are the exact same. And then you run the DataMatch function, and it creates an HTML report down here. The main places you want to look are the row check and the column check. And when these two pass, that's a very good sign. It means your data sets match exactly. So in here, this is the count of the rows for the first data set and the second data set. It lists the primary keys, the number of mismatched columns, the number of columns that are in common, and then the columns that are only found in the first and the columns that are only found in the second data set. And here you see the column names, the data types for each column, the match count, the number of mismatches, and the percentages. Okay, so now we're going to look at what a report looks like whenever there's some issues. So here I'm just adding some extra rows to the second data set, and then running same code again. And this time it shows that the row check failed. That's because there's 4 extra rows in the second data set. However, it does show that all the columns match 100%. And that's because it only compares whenever the primary keys match. And because the added rows have different values for primary keys, they aren't compared. So that's why this shows 100%. Okay, and now here's a case whenever they're not matching. So here we have an extra column in the second data set, and we also changed 2 values. And there is a way, if you have extra columns in your second data set, if you're doing some testing, and so you create extra columns, but you don't want to match or compare those columns, then you want to give it a list of the columns you do want to compare. But if you don't, it'll try to compare all the columns, and then it'll give you an issue, right? So here it'll show columns found only in the second data frame, and it'll give you a count and the name of the column. As for the values that mismatch, it shows that there's 2 columns with mismatched values. And if we come down here, you can see the column names and then some examples. Right now, the report defaults to showing you up to 5 examples. So in this case, there's just 1 for each. And it gives you the primary key value and then the column name for each one. Okay. And so, yeah, so these 2 mismatch, and that's how that report looks when there's mismatch values. And then there's sometimes you'll have different ways to do rounding for decimals. And so for our tool, the default is 4 decimal places is the tolerance level. So anything that's over that will still count as a match, and anything that has a value greater than the tolerance level, then it will count as a mismatch. So here's an example. These are just a couple values that have been altered slightly, and then we come down to the report, it'll show that there's 1 column with some mismatched values, and there's only the 2 that are above the threshold. As for the data type, right now, how it works is it tries to convert the data types so that they match. So even if you give a column of strings for the last row, right? So the first data set, this row or this column is integers, and this one it's strings. It'll convert them to, or try to convert to integers and match on that. So that's why in the report it'll show the number of mismatch columns is 1, and there's only one mismatch, and that's the one that I changed to the word 9, whereas all the other ones match, even though that they're strings. Likewise with decimals. So if you change these to floats, it'll also still match with integers as long as it's within the tolerance level. Okay. And then if you do want it to make sure that the types have the same, or the columns have the same data types, then you can create your own little function and do that. And if enough people ask for it, I'm sure we can build that into the tool as well. But for now, it's pretty short command to do that. And if another fairly common issue is that there's a primary key that isn't unique. So there's going to be values here and here. I changed to 1. So they have the same primary key, and that's going to look a little bit weird in the report. So if you come down here, it'll show that there's 2 values that are mismatched for every row or every column, and one of them is going to look like it should match, and that's an indicator that it's a primary key mismatch. Okay. And for the last case, so this is sort of how to use the tool as an iterative process. So this and this is how to use the tool. Just reading in your files, and this is what this data set looks like. It's different than the ones above. And then we run the report, and we see that there's the row check failed and the column check failed. So real quick, I want to show. So here, this one has 99 mismatches, and because it prints out examples, you can sort of look at these and try to figure out why they're mismatching. So this looks like maybe it's being read in as an integer somewhere. And for down here on the species, it looks like some are being converted to lowercase on the first letter, whereas these are in title format. And so you might want to look at these data sets and do a filter and see possibly why your data set is the way it is. And so here, if you filter on the species and just look at the ones that are lowercase, might find that it looks like the store ID is printing or is doing a lowercase on the species column. And anyway, yeah, you can use the tool to print out examples and then go back and forth and as an iterative process to validate your data and make corrections to the code. Okay. Now I think we have a little bit of time for questions. So I'll stop sharing.
Great. Thanks, everyone. Julia, I think we'll turn it back over to you.
Sounds good. So at this point, I don't see any questions that haven't been answered in the chat. I think your team was able to get to everything. We can give it 1 more minute if we want to see if anything else comes in, though. Okay, so we just got one. How did you move the converted code to Databricks?
Oh yeah, so
I'm
for that
assuming
one,
that's DB, right?
should be, yeah, I'm
Okay.
assuming so. So for that
I'm not
one,
technical. I'm just making sure.
yeah, so when the code finishes converting, you can basically just click on download file. There's going to be a download icon on the converter tab, or you can go into file manager, go to your staging folder and just find your it should take your SAS file name and put a suffix to it on whatever language you convert it to. Click on it and then you can just download it. So either one should work. I can show that right now actually.
Sure.
On 1 second. So let's show. Sorry, give me a second.
You're fine.
Okay, let me share screen now. Yeah, so for example, you can just go here. So I'm in project staging. So right here, the staging folder. You can go to your script, click on one of this, and then click on download, and it should download it at the top right over there. And that's one way to download it. So that's what you can use the file manager to do. So hopefully that answers the question. Okay, that's anything else?
Awesome. I don't see any others at this point, so I think we are okay to wrap up. I'll go ahead and share my screen again, just to run through anything else for day 2. Okay, so thank you so much to the AIM team, and thank you to our many attendees throughout all of day 1. For tomorrow's agenda, we are going to have an additional 4 sessions and then a closing with Katie Holmes. So we have how to create custom logs in Databricks, fast CASA and chatbot overview, introduction to practical machine learning, and then a CCSQ quick site essentials, and then like I said, that closing statement there. So please return back, join us tomorrow at 1 p.m. Eastern time. We hope to see you there. And again, another thank you to all of our presenters today for helping to make day 1 successful. Have a great night, everyone.